Alright, in this video I'm going to be working on some practice problems to help you prepare for test 7 for AP Precal, which is going to be all about graphing trig functions like sine, cosine, and tangent. And I don't need to give you the disclaimer. I always give you the disclaimer. You can read it up at the top. You know what it is. You got to go look at the quizzes too. So if the function h has a period of 3, which of these could be a portion of the graph of h in the xy plane? So we're looking for functions that kind of repeat themselves at intervals of 3. A isn't really exactly repeating itself, so I think I'm going to eliminate that one. That's kind of a weird answer choice. B is repeating itself. It's doing this up-down thing and then skipping an x value. Okay, so that looks like it's periodic. Oh, but the period is 4 because I went 4 from the maximum to the next maximum. Okay, so that one's out. Okay, so I think it's going to be C. C looks periodic, and the tops are separated by 3, and it's doing the exact same thing each 3. So I think that would probably be it. What's the deal with D? Oh, okay, yeah, the overall increase is the same, but the function output values themselves are not demonstrating a repeating pattern. So it's going to be answer choice C. All right, number 2, the periodic function y equals g of x has a period of 6. It's known that g of 1 and g of 7 are both equal to 0, and that g of 5 equals 3 is a maximum of g. Which of these must also be true? Okay, so it must be that, okay, if the period 6 and g of 1 and g of 7 are both 0, that would mean, I think that let me think about that. All right, so let's probably what you would think first. Okay, well, maybe 0 is going to be the midline of the thing, and so then it would be, like maybe up and then down in the middle and then back up there. Okay, but that won't really work for 5 because 5 isn't even halfway in between 4 and 7. So I think what we're going to have to assume is that 0 is going to be the minimum. And I'm realizing that's probably not going to work either because of kind of the same issues of 5 not being equally spaced. Okay, so let's go ahead and say maybe g of 5 equals 3 is a relative maximum. And I'm going to put that one right there. And I'm going to just kind of draw this standard picture and see what happens. So I have this one here. So g of 5 was equal to 3. And that would mean that g of negative 1 was also equal to 3 if the period was 6. Okay, relative maximum, yeah, it's another relative maximum. Okay, I'm thinking that means that if g of 1 and g of 7 are both equal to 0, that does make sense, because 1 is, I don't know, over here, 2 to the right of negative 1, and also 2 to the right of 5. Okay, but maybe that's just some point in the middle on the way, and it will fit just right. All right, function g must be increasing on 0 to 5. No, and decreasing on 5 to 7. 5 to 7 I think is true, but I don't think 0 to 5 is necessarily going to be true. Yeah, I don't think that's... No. Okay, g of 18 is not equal to g of 4. Oh wait, no, g of x is greater than or equal to 0 for all values of x. I think I determined that 0 was not able to be the minimum, otherwise it wouldn't really make sense with the period. Okay, so I think it's going to be one of these things that must be true. G of 3 equals g of 27. Oh, yeah. G of 3 equals g of 27 because the period's 6. All right, so at, a difference of 24, that would just be add 4 periods. I'll be in the exact same spot that I was. Okay, that's answer choice D. That was a whole lot of thinking just to arrive at that one, but I think that was a good question. Okay. Now we've got f of theta is cosine theta if all other necessary conditions, what are the conditions? Which of the following could be modeled by f? A scenario where the period is 1 over 2 pi? No. Okay, well here's period frequency. Okay, so the period for cosine is going to be 2 pi, at least for regular cosine. And we know that frequency is 1 over the period, so frequency would be 1 over 2 pi. And so I'm going to get rid of this one and that one. Initial value for theta equals 0, well that's cosine of 0. And we haven't done any unit circle practice in this video, so like over here, that's where theta equals 0. The coordinates are 1 and 0. Cosine is the x-coordinate, so theta equals 0 corresponds to f of 0 equals 1. And so that's going to be a scenario where the frequency is 1 over 2 pi, and the initial value for theta equals 0 is going to be output value 1. Right. Now, number 4 is talking about f equaling 2 cosine theta and g equaling 2 cosine of b theta, where b is a constant. Period of g is half the period of f. Solving which of these equations gives the correct value of b? All right, so what we're going to say is that period for f is equal to 2 pi divided by b, which was 1. And then for g, period will equal 2 pi over b. And maybe I should call them period f and period g. So period of g means equals half of the period of f okay, so I'm just going to kind of plug in on that. Period of g is 2 pi over b. That's going to equal half of 2 pi over 1. Okay, so 2 pi over b equals 1/2 of 2 pi. That's exactly what I've got there. That's answer choice B. That was a good question. All right, now we've got h of theta equaling a cosine of b theta, where constants a and b are constants. The period of h is pi and an amplitude of 4. What are the values of a and b? Well, amplitude is 4 means a equals 4. And so I'm going to just get rid of these two answer choices, right? Period equals 2 pi over b. So period is pi equals 2 pi over b. That means b is going to need to equal 2. And so I'll say that's going to be answer choice D. Depth of water in a bay periodically increases and decreases with a period of 12 hours. Depth of water in feet at a point in the bay can be modeled by sinusoidal function f of time t measured in hours starting at time 0. Time 3, the depth is 10, and at time 9, the depth is 2. So it's going to be half the period. If these time depth pairs represent maximum and the first minimum value after the maximum respectively, which of these could be f of t? All right, I think we should draw a window. All right, so 10 and 2 are going to be the maximum and the minimum. Okay, that one's not going to be very good, but it's all right. Okay, and that time 3 hours and 9 hours, and the period's 12, so that would be 15, and that makes a lot of sense. Okay, so the midline here, halfway between 2 and 10, is going to be 6. And so that doesn't really help at all because all 4 of these had 6 as the midline. All right, then I think about the amplitude, and that's how far up or down I'm allowed to go, and that's going to be 4, and that doesn't really help me either. Now, I think, I'm starting at a maximum. That makes me think, hopefully can work with cosine. Cosine of some number of t minus 3s, that is my phase shift. Okay, I like answer choice A. I'm going to make sure on the multiplier there, though, is the period, which is 12, equal to 2 pi over b, which was pi over 6. Yes, that looks right to me. I'm going to move on. Yeah, answer choice A. All right. Now, periodic function f has a period of 4. The function's increasing on the input value intervals 0 to 4. Think about that. Okay, so that's one full period it's increasing on. Think about that. I think this might be one of those ones like the first one where it's always going to be increasing. It's not going to be like going down also because, yeah, the period is 4. It does its full thing on an interval of width 4. Yeah, so it's always increasing. So f of 9 is less than... Okay, I think that looks believable to me. Oh. Let's break this down. That's a picture of a function that's increasing, and suppose that's just what the one period of the function looks like. I don't think any generality is lost there. At 8, starting at 8, it would be like 8, 9, 10, 11, and 12. And then if I did starting over at 12 right here, yeah, that's a weird one. Maybe it's kind of like tangent, where how is that going to actually even be possible? Yeah, I'll be honest. The more I think about this one, the more I think that my issue is with that interval being closed. If that was just an open interval, then I would have no problem choosing A. I still believe that A is the best answer, because f of 9 is equivalent to f of 1 right there, and f of 15 is equivalent to f of 3 because of the period of 4. And f of 1 is definitely less than f of 3 because of what they said about the increasing on the input value interval. So I got to think it's an A, and choices B, C, and D are clearly wrong. But there's something a little off about that one. So if f of theta is cosine theta and g of theta is sine theta, where are both f and g increasing? Well, I think that, they're giving me intervals that are kind of sub-intervals of 0 to pi over 2. So what I'm going to do, I'm just going to make a box for both of them. Okay, I can label both of these with their input values. We're kind of graphing both of these on the very standard 0 to 2 pi window, so that makes this pi, half of pi, and 1.5 pi right there. All right, so where are they both increasing? Well, on 0 to pi over 2, blue is increasing, but red is decreasing. In fact, the only place where red is increasing at all is after pi. And so I'll be looking after pi when they're both increasing. That's 3 pi over 2 to 2 pi. Right up here, red is increasing, blue is also increasing. So we answer choice D. Okay, data set of coordinate pairs is modeled by the function f of theta equals sine theta. Model F is consistent with the data set, which is the following should describe the dependent variable values on the interval pi to 3 pi over 2. Okay, dependent variable, that's the output. Okay, and so really we're talking about y equals sine x on pi to 3 pi over 2. So I'm going to draw another window. Okay, sine x, just like I had before. Draw a very standard graph of sine x. Could be better. There we go. And then pi to 3 pi over 2. Okay, so I'm graphed on 0 to 2 pi, so that's pi here. That would be 3 pi over 2. If I were to kind of break out this graph, it would be doing that. Okay, the graph is decreasing. Values should be decreasing. It's concave up, so the rate should be increasing. It'll be decreasing at an increasing rate. So I'll choose B. All right, pendulum swings back and forth toward and away from a point on a wall. Motion of the pendulum is periodic. Distance in inches from the wall, time t seconds, is modeled by f of t is this. What's the least interval of time between moments between the moments when the pendulum is farthest from the point on the wall? Okay, so basically we're looking for what's the difference between the maxima. If that's a graph, that would be a really rough sketch, but that's going to be the period. Okay, and so it's the period of the function, which is going to be 2 pi over b, and b is that multiplier, so that's 2 pi over pi, which is going to equal 2. And which is 2 seconds, so I'm going to say, okay, really, I can stop reading there because I looked and I see that all of them are displaying different periods, and I'm confident the period of this thing is 2. But yeah, exactly, true. The rest of the statement was definitely true. Okay, the graph of the function h is shown above. Which of these could be h of x? Okay, now I'm thinking I see that the graph starts out at a local minimum down there at x equals 0, and so I'm looking for negative cosine. It's like, none of these are negative cosine. That's too bad. Okay, so I'm going to look and see what they've got. They've got sine, all positive sine, so I need to think about being in the midline and increasing. So that'll be this one here, and also there. Those are going to be the kind of phase shift options. And the Okay, so phase shift could either be 0.5 or 2.5, and it looks like it's all 0.5s. So I've got it down to A and D because I've shifted right 0.5. Phase shift 0.5, I should see x minus 0.5 on the inside of sine. And so the amplitude is 2, and so I guess really the difference in these is we're going to have to find the period. All right, so the period is going to be the distance between these 2 points I just marked. This is where I was doing the exact same thing. I was in the middle increasing. And so that would be a period with 2. So 2 equals 2 pi divided by b. That means b is going to need to equal pi, and so I'm feeling like it's going to be answer choice C. Okay, here we've got one that's going to require a calculator, which your test will not, but we can still do this. Just be a good trig. Use the given information to find the values of constants a, b, and c. Okay, so there's not going to be a phase shift. It must be starting at a maximum. Maximum distance is 108.9 million, and minimum is 107.5 million. Okay, so c is going to be the midline. And I'll get that by averaging the maximum and minimum. Okay, so 107.5 plus 108.9, all divided by 2. Now, you could use a calculator for this, but I think that this is within our grasp. We increased by 1.4, so we would just increase by half that to get what's in the middle. So increasing by 0.7 is going to be 108.2. And that makes sense because then I increase by 0.7 more and I would get up to 108.9. So it's going to be the midline. Okay, thinking about it like that does also give me the amplitude. A is going to be the amplitude. Okay, that difference that I went up each time, that 0.7, that's going to be the amplitude. So that's going to be A is 0.7. And then B, I'll need to figure out the period, and that's going to be orbiting every 225 days. So period equals 2 pi divided by b. And I'll multiply across, divide, do whatever you're going to do algebraically. See that b is going to be 2 pi divided by 225, which is not going to be reducible because 225 is not an even number. All right, now we've got some more stuff that's actually going to require the use of the calculator. So based on the function d, Venus is at its minimum distance from the sun at time t equals 112.5 days. Let t1 to t2 represent the time interval between the maximum and the minimum. And so I think what I'm going to do is, we just found an expression for d, so I think they fully expect us to be plugging this into the calculator. So let's do that. A is 0.7 cosine of b is, let me call for a fraction bar, 2 pi divided by 225 t, we'll just call that x, and then add d, which was 108.2. Now I'm going to try zoom fit, see how that goes for me. It's going to be 0. Let's see what that does. Okay, it's really thinking about it. Okay, well, okay, don't love that that window, but I guess I could probably work with that and say instead of going from x minimum of negative 10 to x maximum of 10, I probably could have gone a whole lot. Wait a minute. Let me think about this. All right, yeah, that just goes to show you, I don't think zoom fit always is the way to go. I think this will be a much more natural window, x running from 0 to 225 and y running from 106 to 109. I think that would be a little bit more like it. And then I'll be able to find the maximum, which I know is at t equals 0, the minimum they already told me about, and then I can, I can get some values from that. Okay, there we go. That's a graph of 1 period. I don't even know that was all that necessary, though, because we're going to find the average rate of change of the distance and in kilometers per day. So we just need to find, okay, the minimum was at T2. Okay, so that's right down here at the bottom. maximum was at t1. So what I'm going to do, I'm just going to, well, they actually told me the input value for t2. Flagged it better if they said t2 equals 112.5. Maybe you're supposed to know that. Maybe that was part of the deal here. What I'm going to do, I'm going to call on y1 and plug in 112.5, because what I'm going to do is I'm going to use the average rate of change formula, which we haven't used in a very long time, but we do need to know. That's going to be f of b minus f of a divided by b minus a. So I'm going to do d of 112.5 minus d of 0, which if you remember what that is, then that's fine. But if not, you could just plug in y1 of 0, divided by 112.5, minus 0. And then I will let that compute. And so showing the setup for my calculation, or show the computations that lead to my answer. Okay, for part 1, I'm going to say, all right, d of 112.5 minus d of 0 divided by 112.5 equals negative 0.012, always 3 decimals in this class. And yeah, it already gave me the unit, so I don't need to worry about that. Interpret the meaning of my answer from part 1 in the context of the problem. All right, so that means that on average each day, the distance between Venus and the Sun is decreasing 0.012 million kilometers per day. All right, there you go. You didn't need to see me write that. So for the third part, it says use the average rate of change found in part 1 to estimate the distance from Venus to the Sun in millions of kilometers at time t equals 40 days. So what we're not going to do is go and plug in 40 into the actual model. That would give us, I guess, the exact distance if it was following a true sinusoidal pattern. What we're going to do is we're going to say, all right, at time t equals 40 days, I'm going to say that I started at, where did I start? At the maximum, because it was a regular cosine. That was 108.9. You can't see that anymore, but there it was. The maximum was 108.9. So I think I'm just going to try to think about this logically rather than using a formula. 108.9 was the output value at 0, and I decreased 0.012 million kilometers per day on average 40 times, and 40 is definitely in that interval. So I'm going to say, set it up like that. And say, all right, okay, 108.9 minus 0.012 times 40, and that's going to give me 108.42. You could set up a linear function if you wanted to, because that's really what it is, a linear approximation. But I never really specifically showed you how to do that, and I think that in these type of situations, you're best off just trying to work through it yourself. Try to apply the idea of the average rate of change 40 times to see the net change, and then just apply that net change. Anyway, I thought I had something else. Oh yeah, if I went over here to the graph and I calculated the value at x equals 40, let's see if that works. Yep. 108.506. That's pretty good. And so what we're saying here is, what we did, I'll show you the graph there. We did 108.9 minus 0.012 times x based on the average rate of change. And see, that did go through those 2 points, that minimum, or very close to that. Why did that happen? Oh, it was because I rounded a little bit. It didn't go exactly through the minimum, but it should go through the maximum and the minimum because those are the 2 points we used to compute the average rate of change. And one thing I just noticed that I'll point out before I move it off this calculator screen is that there was a place using that linear approximation where it was perfect, so there was a place where the average rate of change, it was just right. And I think that's a fact that's guaranteed by calculus that you find out about next year. All right, so I think that's going to be enough for the calculator, at least for now. All right, the next one here is the periodic function f has a period of pi, which these could be f of x. Okay, well, I know that tangent x has a period of pi, so I'm just going to choose answer choice B. I don't want to be too fancy here. Okay, the other ones are going to have a period not pi because they're tangent, dilated by some amount. Okay, and here we've got one that is very clearly a replica of free response question 3, which is something we need to be ready for because we're definitely going to have one of those on our test in class. All right, the blades of a windmill rotate in a clockwise direction and complete one rotation every 6 seconds. Okay, then point B is on one tip of the windmill blades and is located directly above the center of the windmill at time t equals 0, very much like some of the other situations we've seen. Point B is 40 meters from the center of the windmill. Okay, so I think that's telling me the amplitude is going to end up being 40. Okay, and then when it said that it completed one rotation every 6 seconds, that's kind of giving me the period. Period is time divided by number of cycles. One rotation every 6 seconds. Yeah, so time 6 seconds divided by number of rotations, one rotation. Okay. And then I will probably also need the midline here. Yeah, it's going to be 75. The center of the windmill is 75 meters above the level ground. And because that's the midline, and I know how these problems go, I know that's going to end up being the value of D eventually. All right, but for part A, we're going to plot the points that we already know, F, G, J, K, and P. Okay, hopefully you've got some good experience with this. Okay, the windmill did start at the top, so the graph is working, like we expect. We said the period was going to be 6. So that means we're going to say, all right, well, if it's starting at the top, I think it would be most logical to say that's t equals 0, and that makes this t equals 6, meaning the t coordinate of j is going to be 3, for g will be 1.5, and for k I'll have 4.5. Okay, and then I will say, all right, what was I thinking here? I lost myself. Anyway, oh yeah, I need the output values, which I usually start with. All right, so we determined that the midline was 75 and the amplitude was 40. So I can start at 75 and I can go up by 40 or down by 40. Okay, so I'll be able to get that input-output pairs pretty easily for these. This one was, I think it was because it gave you a period, not a frequency. Okay, but I'd be ready for the frequency situation. All right, the coordinates of F were 0 and 115. The coordinates of G were going to be 1.5 and 75. For J, coordinates would be 3 and 35. For K, 4.5 and 75, and then P will have coordinates 6 and 115. Okay, yeah, definitely good to take a step back, look at these, make sure you got it all right, because this problem is going to be really important for us. All right, then part B, H can be written, H of t is a sine of B times t plus C, all added to D, find the values of the constants. Well, I already found 2 of them. A is 40 and D is 75. Okay, then for the value of B, period, which I determined was 6, equals 2 pi over B. So I'd multiply that out and get B is 2 pi divided by 6, which is going to be pi over 3. And then C is what I would choose, or is based on what I would choose for the phase shift. And if it's a graph of y equals regular sine x, I'm going to be interested in point K there because it's at the midline and increasing. That would be t equals 4.5 as the phase shift. And so I'll say C equals negative 4.5. Because shifting 4.5 units to the right is going to be equivalent to exchanging t with t minus 4.5. So that would be C equals negative 4.5. Then we'll refer to the graph of h in part A, and the interval t1 to t2 is now going to be talking about the interval between g and j. All right, so I'm going to kind of color on that and then draw a more exaggerated version of it down below. Say, okay, I'm up here between 35 and 75, so that's definitely positive. I'm going to get rid of these answers, which say h is negative, because it definitely is not. The rate of change is negative because h is decreasing, but that's not what they're asking. They're just asking about the output values of h. They are decreasing and positive, so that'll be answer choice B. And then how the rate of change of h is changing, that's going to have to do with concavity. That's concave up. So I'm going to respond that the rate of change of h is increasing, because that's what it means to be concave up. right, here we've got a graph of a tangent function. We've got the figure shows the graph of a tangent of bx, where a and b are constants. Two vertical asymptotes at negative 3 pi over 2 and positive 3 pi over 2. Okay, now normally we would expect the asymptotes to be at negative pi over 2 and regular pi over 2. So I would say that this one has been horizontally dilated by a factor of 3, meaning right now I know that b equals 1/3. What are all solutions to f of x equals 0.813? Well, one of them was 3.545. Okay. But they would repeat each period, because if I had another one of these and, the same exact graph, I could just add one period over there and get this equivalent point. So I'd be plus 1/3 n. Wait, why is that 3 pi? Hold on just a second. Oh, yeah, because it's not plus bn. Okay, that's the idea where I was finding b. That actually, I think, was taking me farther away from what I wanted. What I wanted was that the period is going to be 3 pi. So it's going to be plus 3 pi n, where n is an integer. And so that'll be represented by answer choice D. There we go. Yeah, because it got 3 times as y, the period becomes 3 pi. There you go. That was an interesting one. All right, number 17, f of theta is tangent of theta minus pi over 4, which of the following descriptions is true for the graph of f. All right, so the normal asymptotes would be theta equals pi over 2 plus pi n, where n is an integer. If we're going to shift that right pi over 4 units, I would say, all right, well, I'll just, add pi over 4 to the input values, or just say theta minus pi over 4 equals pi over 2. I think I actually like this better, plus pi n, and then solve, and say, all right, theta equals 3 pi over 4, because if I have 50 cents and I add 25 cents, half plus a quarter, that's going to be 3/4 plus pi n, where n is an integer. So that would be answer choice B. Yes, because it's a tangent function. Okay, I was wondering where that other thing came from, but yeah, you would think plus 2 pi k if you were confused and thinking that the period of tangent was 2 pi like sine and cosine, which, it's an error I've found myself making before. So I would understand if you had, but that's one we need to know. We need to know the period of sine and cosine is 2 pi, and the period of tangent is 1 pi. All right. Graph of f of x equals tangent of bx, where b is a constant, is shown. What is the value of b? All right. Again, I would normally expect these to be at pi over 2 and negative pi over 2. So now I know that the period of this thing is the width between the vertical asymptotes, period equals 6. Right, so period is going to equal 1 pi over b. Okay, so 6b equals pi, and b is going to be pi divided by 6. We answer choice A. All right, 19's gonna have a calculator, and I'm gonna do this one. I'm gonna do a couple more after this. Also, some extra examples from the book that I may not have done in the lesson videos and stuff that I think might be particularly useful for the upcoming test. I'm only half an hour in here, so I think I can do that. All right, the average daily temperature in degrees Fahrenheit in a certain city can be modeled by F, which is this thing that I'm gonna probably be typing into the calculator. Oh wait, the number of days since the beginning of the year, and C is a constant. January 1st corresponds to T equals 1. On January 10th, the average temperature was 41.7. Based on the model, what's the predicted average temperature on February 28th, which is T equals 59? Okay, I'm going to just kind of solve this one on the level of... Let me think about that, actually. It's 41.7... Is that going to be... Yeah, it might be the minimum.
Yeah.
All right, yeah, now if you just notice that, I think that there's a way to solve this one by noticing that t equals 10 is going to be the absolute minimum, and you could like phase shift accordingly, but I really don't think that's the way to go. I think we should just kind of like approach this like we're solving some equations. Yeah, so I'm just going to do that, but I will show you what you could do if you notice that that was a minimum. I think it would take longer. Okay, I'm going to just try to solve this equation, figure out what's the value of c. Okay, this is not something we've really had to do a whole lot in this class, but I think this is going to be a lot of the ones that involve a calculator. We're going to be interested in just like kind of solving an equation, because that's one of the only things we can really do with a calculator in this class besides graph. So what I'm going to do, I might subtract the 41.7 from the 63.6. Now I think, based on what I've got, I'm going to get 21.9, but better safe than sorry. Yeah, okay, that's just how putting together numbers works. All right, so 21.9 plus 20, wait, how is that? Plus 21.9 sine equals 0. Okay, yeah, because it's where the sine equals -1, which is what we already knew in the first place. Okay. Okay, but I subtracted that away, so what I'm going to have is when I subtract that 41.7 from both sides, I'm going to have 0 equaling 21.9 plus 21.9 sine of 2 pi over 365 times 10 minus c. And I can solve this equation. Now, I might try the equation solver, but first I'm going to try it the old way. I'm going to go in here, just clear out whatever I had before, and graph 21.9 plus 21.9 times the sine of, call for a fraction bar, 2 pi over 365 times 10 minus, okay, I don't need to type in c, I'm going to type in x because I'm interested in solving that equation. That'll give me an x value. All right. And then I gotta think that window I had before. Oh no, that window I had before is not going to be good. Okay, yeah, stop graphing. Okay, I'm going to graph this on the window. X equals 0 to 225 should probably be good, but y wants to go from -10 to 10. So I can definitely see the 0. I want to see it passing through the x-axis. And so then there we go, and I think, yeah, I could change the scale up a little bit, maybe made it graph a little faster. Okay, that's not good. There's only going to be one place where that happens, so I'm going to calculate a 0. Let's see if it'll let me do that. Calculate a 0. Left bound, let's say, all right, there, right bound. Right, it's going to just barely touch because that's the actual minimum. Only one possible value of c. Please let it be a whole number. Okay, it's definitely not. All right, so I've got c equals 101.250. Okay, great. Wonderful. Now I'm interested in actually the average temperature on February 28th, which is T equals 59. So I've got my formula. F of T is 63.6 plus 21.9 times the sine of 2 pi divided by 365. It's annoying. Times, what was it? 10 minus 101.25. Got a calculator, might as well have the calculator do that. 101.25. And there we go. And I think there we go. That's the whole thing. So 41.7. What just happened? Did I plug in? I plugged in 10. Of course it gave me 41.7. Okay, that was a huge mistake. I was interested in input value 59. So instead of 10, I want to replace that with 59. And since I made that error, I could just go call up the same thing instead of typing all that in again. That would be really, really annoying. It's going to be annoying enough to just click around to the left, call that a 59, and then let it go and get 49.039040. Yeah, there we go. It's answer choice A. All right, that was number 19. Now I'm going to switch over to the extra example problems from the notes books. All right, but actually first I said I would show you how to do this if you had noticed that you were actually setting at a minimum at t equals 10. If you'd done that, you could have kind of drawn a negative cosine graph and been like, okay, well, the period's 365, because it's a year, it's a yearly thing. And then the phase shift for sine would be where wherever I'm at the midline and increasing. And so that would be, a quarter of the way through the period. So 10 plus a quarter of 365, and that does give you 101.25. So that's how you could have done it. And I don't know, maybe that would have been faster. Depends on what you see first. All right, now let's do some of these extra examples. So let g of theta equal tangent of 3 pi theta. Write an expression that gives all vertical asymptotes of the graph of g. Well, the vertical asymptotes of the graph of y equals regular tangent theta. Vertical asymptotes are x equals pi over 2 plus pi times n. And that's something I'm just recommending that you know. Okay, that's especially for this test right here. I don't know about in the long run. I think, definitely for the AP exam, also probably need to know that. But for y equals, or g of theta equals tangent of 3 pi times theta, okay, what I would point out about that is that's a horizontal dilation by a factor of 1 over 3 pi. Okay, so the vertical asymptotes of this guy are going to be x equals, okay, I just got to horizontally dilate these vertical asymptotes. The x coordinates of them at least. And so there we go, and I'll distribute these, and I'm going to get x equals 1 over 6 plus pi divided by 3 pi is 1/3 of n, where n is an integer. Right, the next one's like, hey, here's a picture of the graph of h of x equals some function related to tangent, and which of these things is true about a and b? All right, well, the first thing I notice about this is that as I move left to right, the arms are going downhill. Okay, and for regular tangent, as I move left to right, the arms are going uphill. So I know that a is negative, and so I'm going to get rid of these answer choices that have a being greater than 0. And then as far as b, that has to do with, am I horizontally dilated by, am I getting wider or am I getting narrower? And now, like I said before, the standard place where you would expect to have vertical asymptotes for y equals tangent x would be like pi over 2 and negative pi over 2. And that would be here and there. So you can see that those got pushed out from the y-axis. I got horizontally dilated by a factor larger than 1. So that means that b will need to be less than 1, because the horizontal dilation factor is 1 over b. So b needs to be less than 1, and so I'll say that's why I'm going to choose answer choice D. Then if they ask me, what's the period of f of theta equals 2 tangent of pi over 5 times theta plus 1? Okay, well, remember, there is going to be the value of b, and the period for a tangent function is pi divided by b, and b equals pi over 5. So that means the period will be pi divided by pi over 5, and that's period equaling 5. Let's see if there's any others. All right, now I just had another look at the multiple choice section of the test, and there's a lot of applied scenarios that I don't want to exactly spoil for you, and there's a lot of kind of looking at a scenario and determining what's the amplitude, what's the midline, what's the period. So I think that this is actually going to give me a good bunch of stuff to work with here, and then we could answer all of these questions. And sometimes they won't ask for the amplitude, they'll ask for the value of a and a sine of b, whatever, or they'll just ask for the amplitude. You got to be ready for all these things. But what I'm going to do is I'm going to draw a box, okay, and say consecutive extrema occur at 1, 5, and 4, 10. Okay, well, that means that 1, 5 is the minimum because that's lower than 4, 10. So that's x equals 1, kind of off the screen. Make that a little smaller. That's fine. X equals 1. What's going on here? Height would be 5, and then the maximum, I'm going to draw this as like a negative cosine graph, I guess. It doesn't have to be perfect, but I think this is the way to go if you're trying to answer these type of questions, is to just draw yourself a little replica of the graph. That's my advice. So, and 4 would be right here, and the output would be 10. So I think I don't know, it's up to you. What do you think is easiest? But, midline's going to be halfway in between the maximum and minimum. And so in our case, that would be halfway between 5 and 10 would be 7.5. And so I would say, like, if they ask for, usually it's the value of d, that would be 7.5 there. Okay, the period, that's the distance between one minimum and the next. And so I saw that the distance from the minimum to the maximum, which has to be half the period, was 3. So I'd add another 3 and I would get 7, and so the period would be 6. Okay, and then the amplitude, that's going to be the distance from the midline to each of the extrema. That'll be 2.5. It's half the difference. But I don't really like to think of it as half the difference. It's just like hard to remember when you add and divide by 2 and when you subtract and divide by 2. I just like to find the midline first by averaging what's halfway in the middle, and then measuring the amplitude by going from the midline to the extremes, because it's usually pretty easy to do in this class. All right, now past that, I think you're going to need to go back and look at the quizzes if you feel like you still need more practice. I think this has been a pretty good set. I think there could have been a lot more of, like, if there was anything I feel like we were missing, it's the stuff that was in the notes and the homework and stuff, that applied scenarios where you're finding amplitude and midline. But that was one of these right here. So that's going to be all for this video. Thanks for watching.